Now we have this joint of sets. We say two sets are called disjoint if there is no any common between them. That means if the intersection of two or more sets is an empty set, that means those sets are disjoint. As you see here, we have A intersection B is an empty set. That means there is no any common between sets A and B. So that's why we say the sets A and B are disjoint. And it is the Venn diagram of two disjoint sets. As you see here, we have no intersection between the sets. Okay. Here we have two sets, A and B. A is the set of 1, 3, 5, 7, 9, and 11. And also B is 2, 4, 6, 8, and 10. As you see here, there is no any common element between A and B. That means that their intersection is an empty set. So you can say A and B are disjoint. We say these two sets are disjoint. And we have difference. When we say A difference B, that means A minus B. That's something like that. It means A difference B. It means the set of all those elements which are in A but not in B. We just subtract the common elements from set A. That's disjoint. We say, so that's difference. If we have A difference B, it means we're going to write down all the elements of set A which are not in B. As you see here, you have a Venn diagram. It's set A and this is set B. This area is the intersection of sets A and B. We just subtract the intersections from set A. This means A minus B or A difference B. This means A difference B. We say A difference B is the set of all those elements in A which are not in B. Here we have an example. We have the set of A, which is 1, 2, 3, 4, up to 8, and B is 2, 4, 6, 8, and 9. For A difference B, we write down all elements of A. Look, 1, 2, 3, 4, 5, 6, 7, and 8. We are going to write down all elements of the first set. Here, so read as A difference B. Now we are just gonna delete the elements which are in B. What are the elements of B? 2. Here we have 2, so we are gonna delete this one. We are gonna delete this one. 4. We are gonna delete this one also. 6 and 8. We are gonna delete these elements from A. We said A difference B means the set of elements of A which are not in B. The elements must not be in B. That means A difference B is 1, 3, 5, and 7. This is A difference. Okay. For the other one, here we have B minus A, B difference A. For this one, we are going to write down the elements of B, which are 2, 4, 6, 8, and 9. Now, we are going to delete the elements which are in A. 1, we have no one here, so that's okay. For 2, we have 2, so we delete this one. As you see, 2 is in A. 4 is in A, we delete it. 6, we delete it. 8, we delete this also. The only element that we have in B difference A is 9. So B difference A is 9. Okay, that's how to find the difference of two elements, two sets, sorry. Do you have any question? Okay. Now you have symmetric difference. Symmetric difference is denoted by this symbol. Okay, that's plus circle. You have a plus in a circle. This symbol is called symmetric difference. It means A difference B union B difference A. If you have two sets, if you have A symmetric difference B, it equals A difference B union B difference A. Okay, may someone else write down to us B difference A union A difference B. It's okay if you write down any of these first, because here we have union. Union is commutative. That means if you have A union B, it equals to B union A. Okay. So this is symmetric difference. That means the set of all elements in both sets except the common ones, except the common elements of both sets. You write down the elements of both sets and then extract the common ones. Here, this set, this and this is A difference B or B difference A. A difference B, A symmetric difference A, say A symmetric difference B equals to B symmetric difference A. These are equal. Okay. Here we have an example. We have sets A and B. To find the symmetric difference of these two sets, we are going to write down the elements of both sets. Then we extract the common ones. Or we are going to find A difference B, then union B difference A. What's A difference B? What are the elements in A which are not in B? As you see here, 1, 2, 3, 4 is not in A difference B. 5 is not in A difference B. That means A difference B, this one, is 1, 2, and 3. We just write down the elements of A which are not in B. Union B difference A. We're going to write down the elements of B which are not in A. Here 4 is in A. We are not going to write down it. 5 is in A. We are not going to write down this also. 6, 7, 8 are not in A. That means B difference A is 6, 7, and 8. The union of these two sets is, so A symmetric difference B is it equals the union of these two sets. And we talked about union before. We said the union of two sets is the set of all elements of both sets without repeating elements. Here we have 1, 2, 3, 6, 7, and 8. This is A difference B. In another way, we can find A difference B. We are gonna write down the elements of both sets, their union, without the repeating ones. I mean, without the common ones. Here we can say A symmetric difference B is, we are going to write down the elements of both sets. 1, 2, 3, 4, 5. Then we have 4, 5, 6, 7, and 8. Here we are going to delete the repeat ones. We have 4, we delete this. We have 5, we delete this. So what's left? Only 1, 2, 3, 6, 7, and 8 equals 1, 2, 3, 6, 7, and 8. This is the symmetric difference of A and B. Okay? As you see, you got the same results as you did here. Both symmetric difference تنها element ها بشكل درهنين how means. Okay? Now you have complement. Complement is noted by the complement of A is noted by A prime. A prime. In some resources, it's noted by A to the power C. This A complement. In some resources, it's written like this. But here, we are going to write down as A prime. We say A prime are the set of elements which are in the universal set, but not in the set A. Here, we say A complement is the set of all elements which are in the universal set, but not in the set A. As you see here, if this is set A, and this is the universal set, we say A complement are the elements which are not in A. That means these all are the complement of A. Use another color for these elements which are here are A complement. If you have A and B here, as you see, this is A and this is B. A complement is the green area. A complement is the green area. As you see, it's the set of all elements which are not in A. Only these are not in the A complement. All the other elements are in A complement. It will be much clear in this example. Here we have the universal set. If you are asked to find the universal set, the complement of a set, the universal set should be given. It should be given. Even if it's not given, you should find a universal set for the sets which are given. But generally, it should be given. Here, this is the universal set, which is 1, 2, 3, 4, 5, 6, and 7. This is the universal set. And the set A is 2, 4, and 6. 2, 4, and 6. To find a complement, we are going to write down the elements of U. But we extract the elements of A from it. Here, we say A complement is U difference A. That means we're going to write down the elements of U which are not in A. Here, we have the elements of U. 1 is not in A. 1 is not in A. We are going to check element by element. 1 is not in A, so you write down here. 2 is in A, so you don't write down this one. 3 is not in A. We write down it. Then 4 is in A. We don't write down it. 5 is not in A. We write down it. And 6 is in A. So 7 is not in A. These elements are A complements. Okay? This set is the set of A complements. As you see, it's the set of elements of U which are not in A. Okay? Or we can say we just subtract the elements of A from U. Okay, here the elements of A are these three elements. You extract these elements from U, and what's left? It would be a complement. Now we have some set identities or properties. Here you have the properties of sets. First, we have commutative law. Commutative law we say the union and intersection is commutative about sets. That means if you have A union B, it equals B union A. And even for intersection, if you have A intersection B, it equals B intersection A. وتعالوا دور commutative. خاصيتي على دور. Okay? Here, A union B is equal to B union A. Even for intersection, A intersection B equals B intersection A. Here, during the exams, if you are asked to find A union B, it's okay if you find B union A. Both are the same. Okay? Any of these, you'll get the same result for each, even for intersection. Now you have associative law. Associative law وقتها خاصية البستن. Here, if you have three sets, if you want to find the union of these three sets, we can do the first two sets first, and then doing it with the third one. And even we can do the last two sets together, and then doing it with the first one. If the operation is union for all, look, this operation is union, and it's also union. And here also, both are union. If both of operations are the same, we can apply the associative law. And for intersection, if we have the intersection of three sets, we can find the intersection of the first two sets first, and then finding it with the third one. And even we can do the last two sets, finding the intersection of the last two sets first, and then finding it with the first one. Okay? And you have distributive law. خاصيتي بشينوي بير. Okay? If you have A union B intersection C, if the operations are different. As you see, this is union, and here we have intersection. If the operations are different, we can say it equals A union B intersection A union C. It equals to that. We say A union B intersection C union bracket. We say it equals A union B intersection A union C. Okay, that's it. And for intersection, if we have A intersection B union C, we say A intersection B union A intersection C. Okay, and even here it's the same. A union B intersection A union C. Okay, is that clear? Okay. Now you have identity. The identity set in union is an empty set. Identity manay. Okay, that means if we add or if you find the union of any set with empty set as the set itself. That means the identity set regarding union is an empty set. You can say if you find the union of any set with an empty set is the set itself. And for intersection, the identity set is the universal set. If you find the intersection of any set with the universal set is the set itself. As you said, all the sets are in the universal set. That's why if you find the intersection of any set with the universal set is the set itself. And complement law, we say to find the union of a set with its complement. Let me return to the Venn diagram here about complement. That's it. We say A, this is A, and this is a complement. Okay, the union of these two is the universal set. And here, this is A, and the green area is a complement. The union of these two is the universal set. That means if you find the union of any set with its complement, we get the universal set. And the intersection of any set with its complement, there is no common between A and its complement. As you see here, and we have this is set A, so this is its complement. This A complement. So the intersection of these two is an empty set. You see, the intersection of any set with its complement is an empty set. So if you have double complements, the complements cancel each other. So these two are cancel each other. So it's left only A. If we have double complement for a set, we get the set itself. Now we have idempotent law. The union and intersection of any set with itself. Here we have A. A union A is still A. A intersection A is still A. If we find the union and intersection of any set with itself is the set itself. We say the union, here we have universal bound law. If we have the union of any set with the universal set, since all the sets belong to the universal set, that means the union of any set with the universal set, we get the universal set. That's it. And the intersection of any set with an empty set is an empty set, because here we have no common elements between these two sets. In an empty set, we have no elements. And we have De Morgan's law. For the De Morgan's law, we say A union B complement. And we have the complement of the union two sets. We say we can give the complement to each set. And if the operation is union, it becomes intersection. It becomes intersection. So the union becomes intersection, and you can give this complement to each of these two sets, to A and B. So A union B complement is A complement intersection B complement. And for intersection, it's the same. A intersection B complement, it becomes A complement union, as you see, this is intersection, it becomes union. B complete. Okay, this law is called De Morgan's law. Okay. Now we have absorption law. We say A union A intersection B, we can directly it equals to A. It equals to A. We can say it equals to A. Even for intersection, A intersection A union B, it's still A. Okay, if you see A union, any set, let's say C union C intersection A, it equals C. Even if we have, let's say, a W intersection W union, let's say Z, that equals W. Okay. Now we have complements of empty set and the universal set. Here we say this is the universal set. It's the set of all sets. I mean, all the sets are in this set. This is the universal set. The complement of this set, this all is the universal set. The complement of this set is nothing. That means the complement of the universal set is an empty set. And the complement of nothing is the universal set. The complement of an empty set is the universal set. We see the complement of phi, which is an empty set, is the set of all elements which are not in phi. What are the elements which are not in phi? All elements. Okay. That means the complement of empty set is the universal set, and the complement of the universal set is empty set. Here, universal set is the whole set, is the biggest set. But the smallest set is an empty set. So the complement of each of them is the other one. Set difference laws. We say A difference B equals A intersection B complement. If we have A difference B, we can say it equals A intersection B complement. And even if you have A intersection B complement, you can say it equals A difference B. For example, if you have, let's say, C intersection D complement, you can say it equals C difference D. Okay, that's it. So we have another property, which is A union and empty set, property of empty set. If you add empty set to any set, it's the set itself. Because before we said that empty set is the identity with union. So A union empty set is the empty set itself. And A intersection empty set is the empty set itself. Okay. So the union of any set with empty set is the empty set itself. And the intersection of any set with an empty set . We have an example. In this example, it says if A intersection C equals B intersection C, and also A intersection C complement equals B intersection C complement, then prove that A equals B. Here, the given things are A intersection C equals B intersection C. And also, A intersection C complement equals B intersection C complement. What should we do, or what should we prove? We should prove that A and B are equal. So the given things are A intersection C equals B intersection C. And also, it's given that A intersection C complement equals B intersection C complement. We have given these two things. What should we prove? We should prove that A equals B. We should prove this. How? Here we can prove this by taking elements. We let X to be an element in A. We must prove that X is in B also. To prove that two sets are equal, we must show that each of them is a subset of the other one. We can do that. Here we say to show that A equals B, we must prove that we need to show that A is a subset of B and B is a subset of A. Okay? We must prove that A is a subset of B and also B is a subset of A. If we have two sets and each of them is a subset of the other one, means that these two sets are equal. And for this, to prove that A equals B, we must show that A is a subset of B and also B is a subset of A. Okay? How? By taking elements. If we take an element from A and if we could show that X is in B, that means A is a subset of B. You say if X in A, then X in B, it means A is a subset of B and converse. And then we take an element from B, and if you could prove that the element is in A, it means B is a subset of A. Now we took an element from set A. We must prove that this element is in B also. By doing this, we can prove that A is a subset of B. Here, X is in A. So C is a set. C is a set. This element that we took from A, it's either in C or it's not in C. So from this, we can say X. Let me use another color. We say X is in C or not. X in C complement. Look, here we say it's either X in C or it's not in C. If it's not in C, it means it's in C complement. Okay? If an element is not belong to a set, it means that element is in its complement. Okay? So here we say X in C or X in C complement. If X in C, that means X is in A and in C. X is in A and in C. So X in A and X in C. So if we have an element in two sets, it means that element is in their intersection. So X is in A intersection C. Since A is in A intersection C, and A intersection C equals B intersection C. That means X is in B intersection C. So X is in both sets. Since it's in their intersection, it means X is in B and is in C. Look, we took X to be in A and we proved that X is in B. It means A is a subset of B. That's it. And now, similarly, we are going to take an element from B. But before we do that, here in the case if X to be in C, we get that X is in B also. It means A is a subset of B. In the other case, if X not in C, it means it's in C complement. Since X in C complement, as we have here, X is in A and X in C complement. It means X in A intersection C. If X in C complement, we get that X in A and X in C complement. So X is in A intersection C complement, and this equals to what? This equals to B intersection C complement. It means X is in B intersection C. So X is in B intersection C complement. If we have an element in the intersection of two sets, we can say X is in both sets, which is in B also. Look, in both cases, even if X in C and is not in C, we get that X is in B. So this proves that A is a subset of B. Now, in this case, we prove that A is a subset of B. And now, to prove that B is a subset of A, just change B to A. That's all. Here, all what we do here, just change B, just interchange A and B. You'll get that. Okay? Just interchange them, you'll get the result. So, to prove that B is a subset of C, similarly is a subset of B, sorry, not C. Similarly to the previous one. You get that? So we get that in this case, we get that B is a subset of A. And before we proved that A is a subset of B. That means A equals B. Here, up to here, we proved that A is a subset of B. Similarly, we can prove that B is a subset of A also. That means A is a subset of B and B is a subset of A. And here we can say that A and B are equal. Answer required. Okay, and you are asked to prove that A equals B. Okay. Okay, let's take a break for 10 minutes. So now we have another example. In this example, it says, let A and B be two sets. Prove that or show that A difference A intersection B is equal to A difference B. A difference A intersection B is equal to A difference B. Now we take one of the sides and you must get the other side. You also can work by elements. Okay, you can work by taking elements. You can profit by that way. But here we have an easier way. We are going to take the left hand side and modifying it to get the right hand side. We say left hand side equals A difference A intersection B. We have a property or an identity that says if you have A minus B, it equals A intersection B complement. It is A intersection B complement. Is it? Look, here you have this property. That's it. A minus B equals A intersection B complement. We just take the complement for the second set and we change the difference to intersection. This is a rule. Here we have this set and we just deal with this bracket as a set. So you get that A intersection B all complements. We just deal with this to be, let's say, C. We have A minus C, it equals A intersection C complement. Now we have a complement of the intersection of two sets. We have a property that if we have A intersection B all complement, it equals A complement union B complement. Okay, it equals A complement union B complement. It is a property that we talked about before. That's it. If we have A intersection B all complement, it equals A complement union B complement. You should know these properties. That's it. So now, so this bracket becomes A complement union B complement. And we get that A intersection A complement union B complement. Now, by using distributive law, we can say we get A intersection A complement union A intersection B complement. We get A intersection A complement union A intersection B complement. A intersection B complement. We said that there is no common between a set and its complement. That means the intersection of A and A complement is an empty set. This is an empty set. So we get empty set union A intersection B complement. And we said the identity set of union two sets is an empty set. If we find the union of any set with the empty set is the set itself. So you get A intersection B complement. Again, by using this rule. By using this rule, we have A intersection B complement. Can I say it equals to A minus B? Yes, you can. We can say that. It equals A minus B. Since you have A intersection B complement. And you have this, so you can say it equals to A minus B. This equals to the right hand side. So it's the proof. As you see, we start from the left hand side by applying the rules that we talked about, or by applying the properties. we get the right-hand side. That's all. Okay. This is the proof of this example. Now we have the generalized union and intersection. If you have a finite set, let's say A1, A2, A3 up to AN, then their union is the union of all elements of all sets without repeating the elements. Okay, that's it. And for infinite, it's the same. If you have infinite sets, it's the same. We just write down the elements of all sets without repeating the elements. For intersections, it's the same. For finite and infinite sets, it's the same. Okay. Now we have this example. In this example, we have three sets, A1, A2, and A3. We should find their union and their intersection. Let's see what are the definitions of A1, A2, and A3. And what are the sets of A1, A2, and A3? We say AI equals minus 1 over I to 1 over I. Here, we say AI is minus 1 over I to 1 over I. If the index is I, it equals 1 over I, okay, minus 1 over I to 1 over I. How about A1? The index is 1. So we just replace I by 1. We just replace I by 1 here. Yeah, we just replace I by 1. This is AI. If AI to be the interval from minus 1 over I to 1 over I, so A1 equals minus 1 over 1 to 1 over 1. It equals minus 1 to 1. Okay. So A2 is minus 1 over 2. We just replace I by the index. Here, the index is I, so these two is I, are I. If the index is any number, we just replace I by that number. It's minus a half to a half. A3 is minus 1/3 to 1/3. Let's represent these on the real line. On the real line. If this is the real line, this is 0, this is 1, this is -1, this is a half, minus a half, this is a half. This is -1/3, this is 1/3, this is minus 1/3. Okay. Now we are going to represent each set. I'm going to use different colors for each set. For the first set, for set A1, it's from -1 to 1. This is A1. And for A2, A2 is from -1/2 to a half. From -1/2 to a half. This is A2. And for A3, A3 is from -1/3 to 1/3. This is A3. So what's the intersection of these three sets? The intersection of these three sets is A3, is it? It's A3. A1, A2, and A3. The intersection of them is the common area, which is in all sets. As you see, this area belongs to all sets. So the intersection this is the intersection. This is the intersection of sets. That means A1 intersection A2 intersection A3 is the common part which in all sets. Which area or which interval belongs to all sets? Look, set A1 is from -1 to 1. Okay, set A2 is from -1/2 to 1/2, and set A3 is from -1/3 to 1/3. Which one belongs to all sets? From -1/3 to 1/3. Okay, this belongs to A1. This belongs to A2 also. That means the intersection of A1, A2, A3 is -1/3 to 1/3, which is A3. And for A1 union A2 union A3 is the set of all elements without repeating. But here, A3 is a subset of A2, and A2 is a subset of A1. That means the biggest one is A1. So A1 is from -1 to 1, which is A1. The union is A1, and the intersection is A3. Okay, it's the smallest one. Let me explain here better. So let me clean this. And I'm gonna draw each interval on a real line, on different real lines. For A1 is from, this is 0, -1 to 1. This is A1. This area from -1 to 1 is A1. And for A2 is from -1/2 to 1/2. This interval is A2. And A3 this is -1/2, this is 0, this 1/2. And for A3 A3 is from -1/3 to 1/3. Okay, -1/3 to 1/3. This is 0. This is A3. The intersection of them, look, the intersection could be obtained by this way. Which area is in all sets? This is the smallest one. So this includes all sets. It contains in all sets. So what's this area? It's from -1/3 to 1/3, which is A3. So this is the intersection. The intersection is the common interval, which in all sets. But the union is the union of all sets. A3 union A2 is A2, and A2 union A1 is A1, because A3 is a subset of A2, and A2 is a subset of A1. That means the union is the biggest one, is the greatest interval, which is -1 to 1. This is the greatest one. This one is the greatest, which is -1 to 1, and it's also A1. That means the union of these three sets is from -1 to 1, and the intersection is from minus 1/3 to 1/3. And it's repeated this slide. It's repeated. Sorry. أدري أما أدري أما خودي دوسيو سيكا شلون دوسيتو it's given that I equals minus 1 over I to 1 over I. Okay, it's given that here I equals minus 1 over I to 1 over I. If we change this index to any number, we just change these two also. Yes, you should find by yourself. But it's given here A1, A2, A3. Regarding this one, that's why I found A1, A2, and A3. Okay, that's why I found A1, A2, and A3. If it's given A1 union A5 union A8, what should you find? You should find A1, A5, and A8. It depends on the required in the exam. Okay, so let me clean this one. Okay. This is repeated one. Now you have Cartesian product. Cartesian product in multiplying or in finding the product of two sets, we must pick the first element here from the first set. That means in the product of A and B, what should we do? We should take the first element from set A and the second element from set B. Okay, this is a pair. This is an order pair. Okay, here in the order pair, we must pick the first element from the first set and the second from the second, third from third, and so on. And here we say the Cartesian product of A and B is the set of all pairs, the set of all order pairs that you obtained from sets A and B, such that the first element belongs to the first set and the second element belongs to the second set. Okay, that's how to find the Cartesian product. Here we have given an example. We have given A and B. A is A and B. B is 1 and 2. To find the Cartesian product of A and B, and also B and A, these are not equal. If A and B are not equal, then A times B doesn't equal to B times A. These are not equal. For the first one, for A times B, here we say A1, it equals, we are going to write down as a pair, A1, A and 1, A and 2, then B and 1, and B and 2. This is the Cartesian product of A and B. We're gonna write down each pairs that you get in the product. But here, if someone write down 2 and 1, 2 and B, it's different. It's different. It's not correct. Okay. As you have A and B, we must write down the element of A first and the element of B. So B2. And for finding B times A, that's in the other way. 1A and 1B. 2A and 2B. Okay, equals 1A, 1B, 2A, 2B. This is the Cartesian product of B and A. As you see, the elements of A times B are different from the elements of B times A. These two are not equal. Here, it's explained that if the elements of the sets that we find the products are different, then we cannot we cannot change the order of the elements. We should first write down the elements that we took from the first set, as you see here. For this one, we first write down the elements of B, then elements of A. As you see, 1 and 2 doesn't equal to 2 and 1. If the Cartesian product of any set with an empty set is an empty set also. We say if A doesn't equal to B, then A times B doesn't equal to B times A. It's not commutative. We say if A to be M elements, if we have M elements in A, that means the cardinality of A is M and the cardinality of B is N, then the cardinality of their product is the multiplication of the cardinality. Okay, the product of these two sets, if we find its cardinality, if we find the number of elements in A cross B, it equals M times N. M is the number of elements in A and N is the number of elements in B. As you see here in the example, the cardinality of A is 2, and the cardinality of A is 2. The cardinality of B is 2, as we have 2 elements in each of these two sets. So the cardinality of A cross B equals 2 times 2, which is 4. Let's check if you have 4 elements in A times B. 1, 2, 3, and 4. We have 4 elements. What's the multiplication of their cardinality? And if you have n sets that you find their Cartesian product, if you have A1, A2 up to AN, and if you want to find A1 times A2 times A3 up to AN, we get you get all the n tuples that you get from these products. So the Cartesian product is the n tuples. And for the cardinality of a set, I mean, for cardinality of a product, if you have n sets, it equals to the multiplication of their cardinality. If you have 3 sets, let's say the cardinality of A to be 5, the cardinality of B to be 2, the cardinality of C to be, let's say, 3. We say the cardinality of A times B times C equals the cardinality of A times the cardinality of B times the cardinality of C. It equals 5 times 2 is 10, times 3 is 30. Let me write down clearly. It's 5 times 2 times 3, which is 30. We find the multiplication of their cardinality. And here you have 3 sets, A, B, and C. A is A and B. B is 1 and 2. C is X and Y. To find A times B times C, we say A, 1, X. So you have 3 elements in each pair. I mean in each bracket. A, 1, X. Then A, 1, Y. A, B1Y. Then A2X. A2X. A2Y. Then for B, we're going to find all. B1X. B1X. B1Y. B1Y. Yeah, B1X, B1Y, B2X, B2X, and B2Y. That's all elements that you get here. How many elements do we have? 8. And the cardinality of A times B times C is the cardinality of A times cardinality of B times cardinality of C. What are the cardinalities of A, B, and C? Each is 2. So it's 2 times 2 times 2 is 8. And we can get it from this one. We can get it from this one. That's also 8. We have 8 elements in it. We have only this element, this example. I'm just going to explain it and for yourselves. Okay? Try to do it by yourself and it will be enough for today. Here we have C, which is, we have 2 elements in it. D, we have 3 elements in it. E, we have 2 elements in it. Here we should find C times D, D times C, and this one we should show either these 2 sets are equal or not. C times D equals to D times C or not. Of course, they are not equal. C times D times E, we first should find C times D and then times E. Okay? C times D, its cardinality. C times D times E cardinality. Try to find this. If we get stuck anywhere, just let me know. Okay? And enough for today. Let me check the attendance and you'll be free to go.